Hello there guys, in this video I'm going to talk to you about some of the really useful facts that we can use with indices that allow us to do a bit of manipulation. So first of all, a couple of facts that not everyone thinks of I'd like to just mention. First is, does 3 squared to the power of 6 come out as the same value as 3 to the 6 squared? The answer is yes, it does. You can write it out long if you want. 3 to the 2 times 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 3 to the 2. If I simplify that with index laws, I'm going to get 3 to the 12. And similarly, if I write 3 to the 6 times 3 to the 6, I'm also going to get 3 to the 12. Now, this is actually a really useful fact because it means that I can switch these two around because the logic's going to work no matter what numbers I have here. So, for example, if I had 3 to the x and that was all squared, I know that that is the same as 3 squared to the x or 9 to the x, and that's a little trick that can often come in really handy. Okay. Another thing to mention, if I have ab to the power of 4, is that the same as a to the 4b to the 4? Yes, it is. The reason for that is ab to the 4 is the same as ab times ab times ab times ab, which is the same as a times a times a times a times b times b times b, because you're allowed to shuffle the order of multiplication around because it's commutative. Okay, so yes, that's also true. So that means if you have any two things raised to a power, you can break them up like this, which is really useful, and vice versa. If you've got two things to the same power, you can put them together in a bracket. Now I'm going to go through a couple of question types that often come up at A level, and we can start to see how we can really use index laws to help us with some more tricky problem solving questions. So the first one I'm going to do is I'm going to express 5 to the 6 times 625 cubed, all divided by 25, in the form 5 to the n. Now I could, if I had loads and loads of time or a handy calculator, work out what 625 cubed was, times it by 5 to the 6, divide that by 25, and then take my answer and work out what power of 5 I needed to get there. However, that's going to take ages. Instead, I'm going to do this without a calculator, just using index laws and these facts that I know about the low powers of 5. Okay. So 5 to the 6 I'm not going to do anything with because that's already expressed as a power of 5. But this 625 I'm going to express as a power of 5. And 625 is 5 to the 4. So I'm going to write it as 5 to the 4, which is all being cubed. And I'm also going to write the 25 as 5 squared instead. So what I've managed to achieve here is, by using my knowledge of the low powers of 5, I've replaced any base that wasn't a 5 with a 5. And I can now just simplify this using index laws. And if I do it correctly, I'll end up with 5 to the power of some number n, which should be equivalent to that whole big sum there. So 5 to the 4 cubed is the same as 5 to the 12. So I've got 5 to the 6 times 5 to the 12 over 5 squared. The top there, we're going to multiply, so we add the powers together, we get 5 to the 18 over 5 squared, and we've got a division going on there, so we subtract the powers, and that gets us 5 to the 16. So n is 16, and the answer to that should come out exactly the same as the answer to that. Okay, I'm now going to use this kind of thinking to do a solving question as well, which is, again, even more handy for us for future reference. So I'm going to solve 9 to the x plus 7 equals 3 to the 24. And the trick to do this, again, is going to be making the bases the same. So the base is the big number that's being raised to the powers. So this base is a 9, this base is a 3. Both of them are powers of 3. So I'm going to rewrite this one here as a power of 3 to start off with, and I know that 9 is 3 squared. So I'm going to write this bit as 3 squared to the power of x plus 7 equals 3 to the 24. And I can now use my index laws to simplify this bit. If you remember, with your power to a power, you multiply those together. Make sure you multiply the 2 by all of that. Okay, if you want to write a little mini bracket around it, you can, or just make sure you remember to do the whole thing. So I end up then with 3 to the 2x plus 14 equals 3 to the 24. At this point, I've got 3 to the power of something is the same as 3 to the power of 24. The only way that this side can come out the same as this is if the two powers are now the same, because the base is the same, the powers also have to be the same. So I can now write, so I'm going to do it over here, that 2x plus 14 is equal to 24. And I've now got a nice linear equation that I can solve using the scales I already have. So 3x, sorry, it's a 2x, not a 3x. Miscopied that there. Okay, so 2x equals 10, so x comes out as 5. So if I put a 5 in here, this solution, this should come out true. So that would be 9 to the 12, should be the same as 3 to the 24, and it is, because 9 is the same as 3 squared, and you can see there that that works. Okay, so when you've got to solve an equation with indices and you haven't learned about logarithms and exponentials yet, or you just don't want to go there because you don't need to, what you can do is you can make the bases the same, and as soon as the bases are the same, you can equate the exponents, equate the powers. Okay.